Hey guys, and welcome back to C# and Mallorca. My name is Matthew, and in the last video we took a look at inheritance in C#. If you want to see that video, go check it out. I'll put a link to it in the top right hand corner here. In today's video we're going to take a look at lists and collections in C# and also go through a few use cases for them. We'll also take a look at loops and how we can iterate over these collections in C#, which is something you'll most likely be doing quite a bit in the future. As always, if you find this video helpful, please give it a like, and if you want to see more, subscribe and turn on notifications so that you can know as soon as the next videos are available. So, without any further delay, let's get going. When coding, you're more often than not going to be working with lists and collections on a fairly regular basis. Whether it be a list of names, numbers, or other complex objects like person classes or whatever it might be, you're going to need to work with lists of them at some point. C# offers quite a few ways of working with list classes. The most common and my favorite is the strongly typed list class. There are various other types of collection classes that you have available, but we're going to focus mainly on the strongly typed list class. Another type for storing collections of values that you will most likely see on a regular basis is arrays. Arrays can also be quite useful in certain scenarios. Arrays generally aren't as convenient to work with as lists, but they do still have their place. They can be useful when micro-optimizing code, when performance becomes a concern, and there are also some other scenarios in which you'll probably work with them as well. Let's take a brief look at arrays and go through an example of working with them, and then replicate the same example with a strongly typed list, and then we'll take a look at loops to iterate over our lists. As usual, we'll be working with a console application in C#, and I've put a link to the video on how to create a console application in the top right hand corner in case you aren't sure of how to do that. In order to declare arrays, we specify the type followed by square brackets. So we're going to type in int, open square brackets, close square brackets, ages. The square brackets here is what flags this as an array. Then we have a few ways in which we can initialize the array. Two ways that we can use are as follows. We can initialize it to a new instance of an array, but we have to specify the number of elements that we want to have in the array at this point in time. This is one of the things to make note of with regards to arrays. You have to know the number of elements you'll be working with before initializing the array. That's one of the major benefits of working with lists, which we'll see shortly. To initialize it to an instance of an array that stores 5 integers, we can type in equals new int and then in square brackets 5. Note that if we omit the number of elements like this, Visual Studio shouts at us. Another way that we can initialize the array is to actually just specify all the elements in the initializer itself. So we can replace everything after the equal sign with, in curly brackets, 5, 10, 15, 20, 25. We don't need to specify the number of elements when doing it this way because it is already clear in the instantiation that we're working with 5 elements. We can access these elements in the array by using an indexer. Let's have a look at the following line of code. Console.writeLine ages in square brackets 1. You might think that this line of code would print the second element in the array to the console, but indexes are 0 based, which means that the indexes for this array would go from 0 to 4. If we run the program, you can see that we get the value 10 written to the console, which is the second element in our ages array. And in fact, if we try to print the 5th index to the console like this, we get a runtime error because there is no 6th item in the array. Let's change this back to 1. We can assign new values to these items in the array as follows. Ages 1 equals 33. If we run the program now, we can see that the new value is printed to the console. Let's modify this scenario a bit. Let's say we don't know how many ages we're going to have up front. In that case, we could use a list instead. Let's change this variable type to a strongly typed list of integers, which we can do so by changing this to list in angle brackets int. As you can see, we no longer use this initializer like we did for the array, so let's change that to just create a new instance of the list for us by changing this to new list int in angle brackets, open brackets, close brackets. You'll notice that the rest of the code doesn't give us any errors, and that's because it's all still valid for the strongly typed list variable as well. We can still access the items in the collection using the indexes, but now we don't have anything in this list. So if we run the code, we'll get the same error we got earlier when we tried to access an item in the array that didn't exist. Let's go ahead and add a few numbers to this list. We can do this by typing in ages.add 5, ages.add 10, ages.add 15, ages.add 20, and ages.add 25. Now we have the same 5 numbers in this list that we had in the array. If we run the code now, we see that our second value in the array is changed and then printed to the console just like before. Now let's take a look at loops and ways of iterating over collections of items. This is also something that will come in handy quite often in the future. We might want to iterate over all the items in our collection and do some validation and processing on them depending on each number that is in the list. The most common way of doing this is by using the for each loop, and most of the time it relies on the type implementing the IEnumerable interface, which isn't something you need to worry too much about at this point, as most of the lists you'll be working with do implement this interface. The syntax is pretty simple as well. To iterate over our list, we can just type in for each, then in brackets, var item in ages. In the block of code for our for each statement, we now have access to the individual items in the list. We could then write these to the console as follows by typing in console.writeLine item, and then run the application, and we see all our numbers written to the console. Note that during the iteration of the list with the for each loop, we cannot change the values of the items. If we try to do that as follows by typing in item equals item plus 1, you can see Visual Studio shouts at us. In this case, we need to use one of the other types of loops. Let's take this bad line of code out and then take a look at the for loop. To use this loop, we set up the criteria for the loop and then access the items of the loop via the indexes, which we can then freely use to change the individual items as we need to. Let's type in for int I equals 0, semicolon, I less than ages.count, semicolon, I plus plus. Now let's have a look at what we're doing here. The for loop takes in 3 pieces of information. Firstly, the variable we're using as the counter for our loop, which we are calling I, and are assigning at the starting value of 0. Then we specify the condition that is checked each time the loop is iterated to see if it must continue iterating. If this check returns false, then the loop stops processing. Then we specify what happens each time the loop processes. In this case, we are incrementing the value I by 1. That means that each time the loop processes, we increase this value and we continue looping so long as this value is less than the count of the items in our list, which is perfect. Now we can change each value in the list how we see fit by typing in something like ages I equals ages I plus 1. Now if we run our code, we can see that all the values have been increased by 1. Now, what if we want to exit the loop? Let's say we're busy looking for a specific value, and once we've found it, we no longer want to continue processing the loop. If we have 100 items and the item we're looking for is the first one in our collection, we don't want to wait for the loop to continue processing every item before we can carry on with the code. For this, we have the break keyword. Let's say we are looking for number 34. We can type in if item equals 34 console.writeLine found 34 exiting loop break, and run our application, and we can see that the loop is stopped after number 34 is found. Alright guys, let's leave it there for now. In the next video, we're going to take a look at LINQ, which stands for Language Integrated Query, which is just something that makes manipulating lists and collections in C# way easier. If there's any specific topics that you guys would like to see discussed or covered here, please let me know in the comments below. I hope you enjoyed this video, and if you did, please give it a like and subscribe and turn on notifications so that you can know as soon as the next videos are available. Take care, see you next time.